Good afternoon, class. We are looking at exam 2 review, chapter 3, differentiation rules, covering from 3.1 to 3.8. And here's the chain rule. So first, reminding you of something we've done in essence. Find an equation of a tangent line to the graph of the function y equals e to the power of x times cosine x at 0, 1. To find the equation of a tangent line, we need two things. We need a pair x comma y, which is given. And we need the slope, which means we have to differentiate, plug in to find the slope. So first and foremost, we want to differentiate this. We put a raised dot in between, and we are going to use the product rule f times g, this one, everybody. So f prime is e to the power of x times g, which is cosine x, plus g prime. The derivative of cosine is negative sine x times f e to the power of x. I'm going to put it at top so it becomes clear what we are dealing with here. So we have f prime g plus g prime f. The product rule is used here. So we factor the e to the power of x out. We get e to the power of x times cosine x minus sine x. And m is y prime of 0 because the x coordinate is 0. So replace the x with 0. That becomes the slope. E to the power of 0, cosine of 0, minus sine of 0. As you know, e to the power of 0 is 1, cosine of 0 is 1, sine of 0 is 0, so the answer is 1. And now, instead of y minus y1 equals m times x minus x of 1, we're going to use y equals mx plus b because this is the y-intercept and b is 1. So y equals mx plus b results in y equals x plus 1. And now the chain rule. How would you differentiate composite functions? Examples, y equals square root of 10x plus 5, or f of x equals 10x squared minus 1 to the power of 50, and so forth. Use the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. The dx of f of g of x is f prime of g of x times g prime of x, or in Leibniz's notation. If y is a function of u and u is a function of x, then dy dx is dy du dx. So capital F represents the composite function. Its derivative would be f prime of g of x times g prime of x, which means take the derivative of the outer function, the main function, and then multiply by the derivative of the inner function. So, which is a g prime of x. Now, to explain the general or extended power rule, recall that for the basic power rule, the derivative of x to the power of n is n x to the power of n minus 1. So if we want the derivative of g of x to the power of n, we need n, just like that, g of x to the power of n minus 1. And as I mentioned last time, over here, the derivative of x is 1, and if we don't write it, it makes no difference. But here, the derivative of g of x is not 1, and it does make a difference. We must mention it, and that's the idea, everybody. One set of questions that will help us understand this would be some sort of a sinusoidal functions, trigonometric functions, for example, sine 2x. And the way I differentiate sinusoidal functions is that I read y equals sine and I stop, I pause. So the derivative is cosine. But you can't have any trigonometric function without the argument, it is meaningless. So you must use the same argument and then times its derivative. This is the chain rule. You rewrite. Same thing happens here. You say y prime is cosine. You pause. You say, okay, I can't write cosine without any argument. I must use the same argument. The derivative of that is 2x. And there you have it. This one is sine. To the second power. So we use the extended power rule. 2 sine x to the power of 2 minus 1 over 1. And the derivative of that is cosine, or 2 sine x cosine x. Let's look at some examples. Warm-up example where y is given as u to the power of 5. It makes it a function of u. And u is given as 10x cubed plus 2, makes it a function of x. If you want to go by the Leibniz's notation, dy dx is dy du dx. Please understand, if you assume this is a fraction, these two cancel each other, okay? But what does it mean, dy du? Well, take the derivative of this function with respect to its independent variable u, which makes it 5u to the power 4. Du dx, take the derivative of this function with respect to its independent variable x, which makes it 30x squared. 10 times 3, x to the power of 3 minus. And now if I replace the u with 10x cubed plus 2, with 30x squared next to it, putting them together, we end up with, if you multiply these two and put them in front, you get 150x squared times 10x cubed plus 2 to the power of. This question is simple enough. We can find the composite function f of g is f of g of x, which means y is u to the power of 5. So if I want f of g, I'm going to replace the u with 10x cubed plus 2, and I get 10x cubed plus 2 quantity to the power of 5. And work on this using the extended power rule. So, or just reminding you of this composite function, the derivative is f prime of g of x times g prime of x. So 5 times g of x to the power of n minus 1, the same thing to the power of 4, times the derivative of the inside, which is simply 30x squared. And again, we put this next to 5, their product will give us exactly what we got in the first place. Let's differentiate. We are going to see that we can easily use the extended power rule on this question. So we start with n, which is 50. Then this function, same thing, 10x squared minus 1, to the power of 50 minus 1 or 49. This is g of x to the power of n minus 1. Finally, g prime, the derivative of the inside is simply 20x. And if we put these two together, we get 1000x in front. And that's the final answer. What about y equals the square root of 10x plus 5? We have to rewrite this as 10x plus 5 to the power of 1 half to get it ready for the extended power rule. So again, following that, we need the n first, so we need 1 half. Then we need the same thing to the power of n minus 1, so 10x plus 5 to the power of negative 1 half. This is class 1 half minus 1. This is 1 half minus 1. Then we need g prime, the derivative of the inside, which is 10. I hope you recognize 10 and 1 half, the product is 5. And this one, when it goes down, take a positive 1 half, becomes a square root. So this is purely algebra. Y equals 5 times 3x minus 2 to the power of 4. First of all, number 5 is there, just keep it. Then we go with the extended power, this part. For this part, we need the 4, n. Then we need the same thing to the power of n minus 1, so 3x minus 2 cubed. And finally, g prime. The derivative of the inside, the parentheses, just gives us 3. So 5 times 4 times 3, 60. We put it in front, and we are done. So we are dealing with the chain rule. Now, reminding you the derivative of e to the power of x is itself. Also reminding you the derivative of f of g of x is f prime of g of x times g prime of x. Therefore, if instead of the exponent being x, we have g of x, then we have to multiply this by g prime of x by the chain rule. So for example, if you have e to the power of kx, the answer is e to the power of kx times k. So the way I approach these exponential functions, anytime I see an exponential function, I just write the function itself. That's my first step, everybody. I just write it because it's an exponential function. Then I need the derivative of the exponent, which is 10, and I put it in front. You don't have to do it in 2 steps, but it's helpful if you can see what's happening. Okay. Again, I just write the function itself because I'm exponential. Then I look at the exponent and say, okay, I need the derivative of that, which is 2t, and I put it in front. First, I want to rewrite this as e to the power of 2t. So it makes it easier to see the derivative is e to the power of 2t first, times the derivative of the exponent is 2, and you put the 2 in front. Y equals e to the power of 2x over 3. I want to make sure that you recognize this one as 2/3 x. Then we write y prime is itself, e to the power of 2/3 x. Just repeat the function. And then the derivative of that is times 2/3. And you put the 2/3 in front, and you're done. Y equals 5x times 3x minus 2 to the power of 4. We want to differentiate this. So this number class can be put outside, put brackets around what is left, and it will carry on, or you can make it part of x. Because this number is very simple, you don't have to worry about that, but if it's large or too small, you want to do that. I'm going to quickly show you what I mean by that. I'm going to go both ways, starting with calling this one f and calling this function g. And using the product rule. I need f prime, which is 5. This is f. I need f prime, which is 5 times g. 3x minus 2 to the power 4. Plus g prime f, g prime. So I want to work on g prime itself uses the extended power rule, the chain rule. So this plus 4, that's n. G of x to the power of n minus 1. This thing, 3x minus 2 cubed. G of x to the power of n minus 1, 3x minus 2 to the power of 4 minus 1. Times g prime, the derivative of the inside is 3. And now we are done with this g prime. We need f, which is 5x. So what we are looking at, everybody, is f prime g plus g prime f. So this is the f function 5x. This is the g function 3x minus 2. So this entire thing is the derivative of g. And I'm going to put an asterisk next to it. Class, you're done with calculus. Everything else is algebra. So we are going to rewrite this by rewriting this one 4 times 3 times 5x makes it 60x, putting the 60x in front just because we want to make sure that it makes it easy to factor. So the second part, 4 and 3 and 5x, we put it in front. What's in common? Obviously, 5 is in common. What is 3x minus 2? 4 versus 3, we go with the 3. So 5 times 3x minus 2 cubed is the common factor. When we divide this one by this one, gives us 3x minus 2. When we divide this one by this one, this completely goes away. 60x divided by 5 gives us 12x. So we get 3x minus 2 from the first one, 12x from the second one, And obviously, these two add up to 15x. So the final answer is 5 times 3x minus 2 cubed times the brackets. The brackets, 15x minus 2. Now, this is done. What I was mentioning in the beginning is the following, everybody. If you put brackets here, notice the 5 carries. So you could take the 5 out in the first place. I don't think it makes much of a difference here because 5 is a small number, it's easy to deal with. If it's, let's say, 10,000 or 1/3 or 2.5, you definitely want to keep it out because it really messes up the process. So now, when you go through this, the derivative of x is 1. So this becomes 1. This remains the same, and this becomes x. Take a look. 5 remains 1 times 3x minus 2 to the power of 4. And the second part is 4 times 3x minus 2 cubed times 3, which is the same as this one, and times, instead of 5x is x. And I hope you see you can finish it off like this. The reason I'm showing you this, because I want you to decide which one is easier for you. We want to differentiate y equals x squared plus 4x over x to the power of 6. Anytime you have a fractional format, this in this case more specifically a rational function, you ask yourself, can I simplify before I move on? Which means, can I make up two fractions? This one is x, this one is 4x over x. So it becomes x plus 4 to the power of 6. And now we are going to use the extended power rule on that. Let me. So 6 times x plus 4 to the power of 5 times the derivative of the inside, which is 1, and we're done. This one class is G prime. What about this one? Y equals 2x squared plus 9x plus 9 over x plus 3. Well, you ask yourself, can I simplify this? And the answer is, if you can, that means the numerator must have, and you can try it, must have a factor of x plus 3, because if it has any other factor, is not going to cut it. So assume it does have it. And because this is 2, you have to go with 2x. And then divide 9 by 3. You see, you need a 3. And again, you check. It does work because the product of these two is 6x. The product of these two is 3x. And they add up to 9x. Otherwise, you can't do that, everybody. So now we are going to simplify. And y prime is 2. I hope you see the importance of using algebra when possible. What about this one? We have to use the extended power rule and then the quotient rule. So first, 5 sits in front. We start with this one, everybody. 5. Then g of x to the power of n minus 1. This thing to the power of 4. And then g prime. The derivative of the inside. Now this is a fraction that can't be simplified, and we have to use the quotient rule on that. Therefore, we are going to call it f over g. So we need f prime g minus g prime f over g squared here. F prime is 2 times g, which is x minus 8, minus g prime is 1 times 2x plus 3 over g, x minus 8 squared, put it in a parentheses, and square that. All we have to do is simplify the numerator. So this is 2x minus 16 minus 2x minus 3. These two cancel each other. These two add up to negative 90. Again, remember, we're done with calculus. We are doing our algebraic steps. So we have a huge fraction bar. What's at top? Number 5 is at top. 2x plus 3 to the power of 4 is at top. Negative 19 is at top. At the bottom is x minus 8 to the power of 4, x minus 8 squared. So this one, we just repeated. The reason I separate from the top from the bottom, because I want everybody to see this has exponent 4. And now, the denominator obviously is x minus 8, and the exponent is 4 plus 2. The numerator is 5 times negative 19, which is negative 95 times 2x plus 3 to the power of 4. Y equals 4 over the square root of x squared plus 3. Anytime we have a fractional format or a rational format where the numerator is just a number, you don't have to use the quotient rule. Rather, rewrite it so you can use the power rule or the extended power rule. This is x squared plus 3 to the power of 1/2, according to this. And then comes up becomes negative 1/2. So this is elementary algebra, everybody. And now, the extended power rule, first, the 4 doesn't go away. Then we need n negative 1/2. Then we have the function itself to the power of n minus 1. So negative 1/2 minus 1 makes it negative 3/2. So that's it. And now the derivative of the inside, 2x. And that's the end of the story as far as calculus is concerned. And now we use our algebraic techniques to finish the job. For a negative 1/2, the product is negative 2, and 2x is negative 4x. This goes down, becomes positive 3/2, and or to the power of 1/2 is the square root, so the same thing, the power of 3. So minus 4x, the square root of x squared plus 3, quantity cube. Everything that you see here is algebraic step. I hope no one has any problem with those. Y equals cosine 3t to the power of 4. So whenever I come across trigonometric functions, I just read them in the following manner. Cosine and I stop. Now, let me explain a couple of things. The derivative of sine x is cosine x. Sine u is cosine u du dx. Sine of g of x is cosine of g of x times g prime of x. Cosine is negative sine x. Cosine u is negative sine u du dx. And cosine of g of x is minus sine g of x g prime of x. So to help understand this, I'm going to just write cosine and say the derivative is what? Negative sine. But negative sign is meaningless without an argument. So it must have an argument, and you must use the same argument for cosine here. And then by the chain rule, the derivative of the argument, which is 12t cubed, in essence, we are looking at the derivative of cosine of g of x is minus sine of g of x times g prime of x. This is g prime of t. And we put this in front. We get negative 12t cubed with the sine of 3t to the power of 4. All right. So we discussed that the derivative of e to the power of x is itself. The derivative of e to the power of kx, because of the chain rule, is itself times k, the derivative of the exponent. The derivative of e to the power of g of x is itself times g prime of x by the chain rule. Therefore, the derivative here, because I see the base e, immediately I write the same answer, e to the power of tan x. Any exponential, write it. And then I look at tan x and I say, okay, the derivative of tan x is secant squared, so times secant squared, and we're done. What about y equals 3 to the power of x? We haven't dealt with the case where the base is no longer e. And we don't have a derivative for that yet. So let's figure out what we need to do. Let's make it general. Let's say it's b to the power of x, some base. And remember, the base must be positive. And so how do we deal with that? Reminding everybody that ln of e to the power of x is x, e to the power of ln x is x, because the two functions are inverse of each other. And I'm going to use this one to rewrite the base as e to the power of ln b. Take a look at this one. That's what we are using here. So that means I can replace the b with e to the power of ln b, and the x remains. And this means e to the power of ln b times x. Please understand, ln b is a number. Natural log of base is some number, just like k. So now I know how to differentiate this. The answer is itself times ln b. And now I'm going to put it back. E to the power of ln b is b, so I'm going to replace this with b, and I get b to the power of x times ln b. So I'm going to write the same answer here. Is the base E? No. So I need natural log of the base, ln 3, and I just rewrite it without the raised dot, or you can leave it the way it is. It's that simple, everybody. What about y equals 5 to the power of 30x squared? And I hope you recognize this works exactly like this one. The difference is now we need to tag along f prime of x because of the chain rule. In other words, when we have b to the power of f of x, the answer is itself. Ln b because the base is not e, and f prime of x is by the chain rule. In essence, that's the proof of it. So what is y prime? Itself, because it's an exponential format. You look at the base. If the base is e, you're done with that part. It's not, you need ln b, so you need ln 5. Then you look at the exponent. You need its derivative by the chain rule, which is 60x. And you just rewrite it by putting 60x ln 5 in front. So a quick recap. E to the power of x, the answer is itself. Therefore, every exponential, you start with itself. If it's e to the power of kx times k, if it's e to the power of g of x times g prime of x. If it's b to the power of x times ln b. If it's b to the power of f of x times ln b times f prime of x. So always write the same thing. Any exponential function, the answer is itself first. The amount of glass recycled in a community is G of P equals 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that T years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? This is elementary algebra you're just going to plug in. Now, there are two ways to do that, and we're going to stick with just the way it's given without finding the composite function. I'm going to discuss the composite function also. If I put 4 here, I get 16 times 0.1 is 1.6 plus 4.4 is 6,000 people. Over here, we replace the p with 6. When we do that, 6 squared is 36. Half of it is 18. Plus 7 is 25. Square root of 25 is 5 tons of glass. So this part, elementary. The next part is calculus. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now, include units. Always include units. So at what rate and one point in time, that means differentiation. What type of differentiation? Find the rate of what? The amount of class, dg, with respect to time, dt. So we want dg dt. According to Leibniz's notation, dy dt is dy du, du dt, where u is the intermediate variable. So we're going to write it in this fashion. I want you to see that it's the same thing here that I wrote. Now, what is the intermediate variable? As we go from g to t, what is the variable in between? G is a function of p is a function of t. So the intermediate variable is p, and therefore you write dg dp, dp dt, everybody. To find dg dp, we are going to rewrite this as a 0.5 p squared plus 7 to the power of 1/2, and we're going to use the extended power rule on that. So it's 1/2 times the same thing to the power of negative 1/2 times the derivative of the inside. So one more time, 1/2. The parenthesis to the power of 1/2 minus 1 or negative 1. The derivative of the inside is 0.5 times 2p, which makes it p. 1/2. Same thing to the power of 1/2 minus 1 or negative 1/2. The derivative of the inside, g prime of x, the derivative of the inside, 0.5 times 2p makes it p. And then dp dt. So this is dg dp, dp dt. Look at this one, 0.1 times 2t, 0.2t. Now, we have two choices. We can change the p to this function and then use t equals 4, or because at t equals 4, previously we learned p is 6, then we are going to use p equals 6, t equals 4. To do so, first let's simplify. So how do we simplify this? And again, remember, this is dg dp, this part, okay? And this is dp dt. Fraction bar, 1 is at top, p is at top, 0.2t is at top. So basically 0.2 pt. Denominator is 2. Also, this one, when you take it down, becomes 0.5 p squared plus 7 to the power of positive 1/2, which is the square root here. So this is elementary algebra class. I hope everybody's following that. Now, when p is 6, look at the denominator. We calculated here, when p is 6, this becomes 5, right? So this becomes 5, 2 times 5, and this one is 6 and 4. So again, this part is here. The numerator is 4.8 over 10, or 0.48 tons of glass per year. I want to discuss the units so you never make a mistake. dg dt, the units of g over the units of t, tons of glass over year. That's how you get your units. What does it mean? 4 years from now, the amount of glass recycled is increasing at a rate of 0.48 tons of glass per year. Now, what did I do? I used Leibniz's notation. Could we have come up with the composite function? The answer is yes. We could have replaced the p with this, which gives us g over t equals the square root of 0.5. P is replaced with 4.4 plus 0.1 t squared. Then this is to the second power plus 7. However, when we do that, in some instances, whether we go this route or that route, they are similar. The difficulty is almost the same. In this case, if you go with this one, and you can try it, I highly recommend you finish it. You just find the GDT, that's all. This is more difficult, so you have to learn both methods. All right, f of x is x to the power of 4 times e to the power of 2x. We want to differentiate that. We notice is the product of two pieces. We put a raised dot in between, and we call it f times g. And we use the product. So we need f prime for x cubed times g e to the power of 2x plus g prime, the derivative of e to the power of 2x. Remember, the moment you see exponential, just immediately write itself. Then you look at the base is fine. You don't have to worry about it. You look at the exponent times 2. So that's the derivative of e to the power of 2x. That means that's g prime times f x to the power of. And this is the extent of the calculus part, and you're done. Now, of course, you do finish the job by using your algebraic techniques. Notice you can factor the common factor between 4 and 2. 2 is in common, x cubed and x to the power of 4x cubed is in common, and also e to the power of 2x. So the common factor is 2x cubed e to the power of 2x. So if you divide these two, this one by this one, you simply get number 2. If you divide this one by this one, you just get x. So the first piece gives you 2, the second piece gives you x. The final answer is 2x cubed e to the power of 2x times 2 plus x. Factoring is extremely important for applications coming up. All right. Again, we are looking at the product of 9x and x minus 1 to the power 4. You have a choice. You call this 9x or put brackets and deal with x. Both ways work fine. It depends on this number, whether it's a difficult number, that means it's way too large or too small. So just the way it is, this is f times g, and again, we're going to use the product. So f prime is 9 times g means x minus 1 to the power 4 plus g prime. Now the derivative of x minus 1 to the power 4 is 4 times x minus 1 cubed times the derivative of the inside 1, and then times f 9x. So I'm going to write f prime g plus g prime f. So that's pretty straightforward, everybody. And again, we are done. We are done with calculus. So we are going to take the common factor. Now, what is the common factor? Obviously, 9 is in common. X minus 1 is in common. And we have exponent 4 and 3. We use the smaller of the two. 9 times x minus 1 cubed is what is used. So when you divide this one by this one, you get x minus 1. And when you divide this one by this one, you get 4 and x, just 4x. So these two add up to 5x. So you get 9 times x minus 1 cubed times 5x minus. And as I mentioned in another example, you could put brackets here and notice this number 9 carries everybody, if that makes it easier. Now, I don't think it makes much of a difference in this case, but it does make a difference if this number is involved, like it's a large number, or it's a fraction, or it's a decimal answer. Y equals cosine to the power of a 10 sine x cubed. The very first thing I want to do, I want to rewrite this so everybody can see 10 is the exponent for cosine. In other words, it's the exponent for the main function. Cosine is the main function. In fact, if you want, you can even call this g of x. So what you need is to differentiate cosine of g of x to the power of 10. So we are using the extended power. First, we need 10. Then we need cosine to the power of 9. But cosine to the power of 9 of what? You can't write it without its argument. And the way you write this, I want to make sure we understand this is the same as cosine of sine x cubed to the power of 9. That means the same thing, everybody, okay? So if it helps, you can write it in that fashion. So now, so 10 cosine to the power of 9. And now you need the derivative of the inside. So let me actually erase my work and tell you what we need to do. Now you need to differentiate this cosine of sine x cubed. So what is the derivative of cosine? Negative sign. But negative sign of what? Same argument. So negative sign of the same argument. Or negative sign of g of x. Finally, we need g prime of x. That means we need the derivative of sine x cubed. What is the derivative of sine of x cubed? Sine cosine x cubed times the derivative of x cubed, 3x squared. So let me erase my work and recap. Cosine to the power of 10, we need 10. Then cosine to the power of 9. Then the derivative of this entire thing is needed, which is this one. What is the derivative of cosine? Is negative sign, the same argument, and then the derivative of sine x cubed. Cosine, it's the same argument, and then the derivative of the argument. So now we put 10 negative sign and 3x squared together, we get negative 30x squared cosine of x cubed and then cosine to the power of 9 of sine of x cubed and sine of x cubed. So I hope everybody is fine with that. It's pretty straightforward, and this is as difficult as it gets, everybody. I hope everybody's fine.